Okay, we're going to learn section 6.5, solving polynomial equations. We know how to solve by factoring for quadratics, and so we're going to be using some of those methods to help us factor some of these polynomials of degree of 4 and then a degree of some higher. Then there's some new ones, some cubes and sum of cubes and difference of cubes. I got to show you, so that part will be new. So let's jump right into a degree of 4 problem. They're going to ask you to take a degree of 4 and put it in a quadratic form. I'm going to show you how to do that last, but to solve it, if it's set equal to 0, what you want to do is kind of think about it as though it was x squared and an x. And that's when we're factoring, we think about what factors of a negative 15 when added together would give us a positive 2. And that would be a positive 5 and a negative 3. So you can actually use the quadratic method to help you do this. You just got to remember that you're going to be not using x's here. You're going to use x squares. Okay? And then you're going to do plus 5 and the minus 3. And you can FOIL this and see. You will get back x to the 4th. You get a plus 5x squared and a minus 3x squared. Turns into positive 2x squared. And then the last is negative 15. So it actually works. It's not a bad method. But because we're solving, we've got to set each one of these equal to 0. I think the majority of your problems are going to be solving, so they'll be set equal to 0. So most of them are going to be worked like this. But I think there's one that's going to ask you to put this back in quadratic form. So I'm going to show you that last. Solve for the x. So subtract the 5, and then you square root it. And when you square root it, you got plus or minus. Don't forget that. And we got a negative under there, so remember to pull out the I, and the 5 stays there. Okay, so x squared equals 3. Square root it, you get plus or minus square root of 3. This is 2 imaginary answers. This is 2 irrational answers. And it's a degree of 4, so it has 4 answers. It has 4 zeros. So let me show you that quadratic form they're talking about. That would be where they didn't have it set equal to 0. Okay? So all they want you to do is really kind of strange. They want you just to replace the x to the 4th as x squared. And then they want you to do this. And I think they want you to do that squared minus 15. And so it is the same problem, it's just they want you to look at it differently. So it's an x squared quadratic instead of the degree of 4. Okay, let's do another one of these because the majority of them are solving. So you're going to look at the 8 and what factors of a positive 8 when added together give you negative 6. Well, this one means both need to be negative. So you can get a positive 8 product, you can add and get negative 6. So you can go build your 2 parentheses. But remember, you don't want just x's, you want x squared. So minus 4, minus 2, set both equal to 0 because you're solving. So we have x squared equals 4, square root it. So we have x plus or minus 2, and this will be square root it, x equals plus or minus square root of 2. So you got 4 answers again. These 2 are rational, these 2 are irrational. That's degree of 4. So that makes good sense. Okay. We also know how to do pulling a GCF out. There's a whole bunch of problems today that you're going to be pulling a GCF out first before it even looks like a pattern that you're familiar with. For instance, this one, you need to pull the x out first. Then it turns into a problem you know. That's the difference of 2 squares. X squared minus 36. So look out for those perfect squares. If you have to, make a list of perfect squares. So to finish this, you would factor it all the way down to x times x plus 6 and x minus 6. Okay, here's the new stuff. Sum of 2 cubes. You need to learn the perfect cube numbers. Like 1's a perfect cube number because 1 to the 3rd is 1. 2 to the 3rd is 8. 3 to the 3rd is 27. Any bigger numbers, just take that number. If you think it's a 4 to the 3rd, find out what it is. 5 to the 3rd is 125. So if you need to figure that out, use your calculator, just raise it to the third power, because you're going to have to recognize those. I mean, it's clear this is an x cube and a y cube, so you know it's a cube. Well, these have a certain pattern. When you factor the sum of two cubes, it factors down into a binomial. I'm going to write it just like we would see it in parentheses, and a trinomial. Okay? So the pattern is always the same. So I need you to look at this pattern, and then I'm going to go through it with you. So to get the binomial, it's just cube root that, you get x, cube root that, you get y. Plus, you put a plus. This binomial helps you write the trinomial. If it's x who's leading, square it. And that gives you the first term of the trinomial. The back term of the trinomial is this back term squared. So those two are easy. It's this in the middle that you got to watch out for. The middle has to be the opposite sign of when you multiply all of that together. So if you multiplied all of that together, you would get x times y, and it would be positive, but you need the negative. And so this is the pattern for the sum of two cubes. Copy it down, highlight it, memorize it. Okay? Now, the sum of two cubes has a partner formula or form, and that is the difference of two cubes. The difference of two cubes, it's just going to have a minus in between two perfect cubes. And the pattern for it is just like this pattern, except we've got the switch of the signs. And so I want to run through it again with you. And this time I'm going to fill in everything so you can watch me. So if I had these two, the difference of two cubes, I take the cube root of that and I get x. Cube root of that, I get y. Since there's a minus, you put a minus. Once you have the binomial, you use it to help you write out the trinomial. So remember that. Use this binomial to help you write the trinomial. So I can do the front and the back really easy. This guy needs to be squared. Okay. This needs to be squared. Well, negative y squared is a positive y squared. Now, the middle, I told you got to be real careful here. You want to multiply all that stuff together. On all that stuff together, when you multiply, it would be a negative xy. So you want to write xy, but you want a plus, because they need to have two different signs, so they'll cancel. And you could take, the old method of breaking them apart to check and say x multiplied all the way through, negative y multiplied all the way through. And when you do that, you should get back to just this answer. And so in order for all that stuff to cancel out, these signs have to be different right there. So we're going to practice some of these. They'll be mixed with some things that we have to do GCFs on. Again, make sure you know your perfect cubes, so you may need to study some of those numbers to recognize when you're dealing with it. So let's do a few practice here. So here we're starting off with a 12. It catches my eye. We're not used to seeing Q's and W's. That looks a little weird. But what we're going to do is look for GCF. They both have 12s, and they both have a Q. So pull that away. So then we have W cubed minus Q cubed. That's hard to say. Now, this GCF, don't lose it, but there's nothing else to do with it. You don't have to factor it any further. But this, my friends, is the difference of two cubes. So use that same pattern. I know they're different variables, but it's not bad. You can handle it. So it's going to turn into, I'm going to go ahead and keep the 12 cube. And then remember, it's going to factor into a binomial and then a trinomial. So here we go. So take the cube root of W cubed. W, whatever sign, put it there. Cube root of that is a cube. Now once I've got the binomial, it's going to help me generate the trinomial. So square the W, square the Q. Now multiply all that little stuff right there together and you get WQ. I don't even know what the alphabetical order is. Q, W, I guess. And then we're going to do positive. Remember, opposite signs. These two need to be opposite signs. By the way, the trinomial you get never needs to be factored again. So remember that. Don't waste your time, okay? Trying to factor that trinomial. You'll just spin your wheels because it won't ever happen. Okay, so let's see another one. Okay, I'm pretty sure c cubed, d cubed, they're cubes. And then 8, I already told you that one is a perfect cube. 125, it is also a perfect cube. Go test it. 5 to the 3rd power, and it is 125. So it will work. So let me show you how this is going to go. So you're going to have a binomial and a trinomial. So here we go. Take the cube root of 8. That's 2. Cube root of c cubed. That's c. Whatever sign's there goes there. The cube root of 125 is 5. Cube root of d cubed, d. And remember, once you get your binomial, use it to help you generate the trinomial. So square 2 and c. And then go square the 5 and the d. You see how that works? So you got to get this right in order to get the trinomial right. Now the middle, what we got to do is take all this and multiply it. 2 times -5 is -10, and then dc or cd, but it needs to be a positive because that's negative, that needs to be positive. So we want 10 and then c and d. And I already told you that trinomial, don't waste time trying to factor it because you don't have to. It's not going to happen. Okay, this one looks kind of big. Let's see what we're going to do here. Looks like we have a greatest common factor. And it looks like I need to probably pull this up because this one I think gets kind of big. This is a pretty challenging one. Let's see if I can get this finished. So a to the 2nd is our GCF. We're going to pull out. So that means 8 minus 2, that'll be a 6. Okay, so that's GCF. It's not going to be factoring anymore. This guy is difference of 2 cubes. And it's a little awkward, I think. So some of you may be a little challenged by this. We're going to do and I probably can show it to you better down here. A to the 6th, you got to take the cube root of that. That turns out to be a to the 2nd. So you're going to get a squared, and then we're going to get minus b squared, and then we're going to use those to build the trinomial. So same thing, if you did the cube root of b to the 6th, you get b squared. Okay, so we got our binomial. Square this, a to the 4th. Square this, b to the 4th. And then take them together, multiply them, but change the sign. So that'll be a squared, b squared. This can't be factored any further. But this can, and this is why this one is tricky. This is the difference of 2 squares. Oh my. So maybe you might have seen it, maybe you might not see it. So that factors into that. And we need to take the little GCF back. So there was a lot to write down for this answer. B to the 4th. I think I got all that. Okay, so let me back up. Pull the GCF out. We were left with a to the 6th minus b to the 6th. Then we had to notice they were differences of 2 cubes. And then take the cube root, a squared minus b squared, and then use those to get your trinomial. And then those factored into a plus b, a minus b. So, wow, that was the final answer.